Hello, everyone, and welcome back to my online teaching platform. We are still on application of differentiation in relation to normal and tangent to a given curve. All right, we have a problem here, and we have to find a solution to the problem. There's a curve y is equal to ax squared plus bx minus 3 passing through a point P with x coordinate of 1 and y coordinate of -5. It is given that at that point, the curve has a gradient of 2. Okay, if its gradient at P is 2, we have to find the constants A and B, the given curve. All right. Now, anytime we know that anytime we have a curve passing through a point, or we have a point on a curve, it implies that the point must satisfy the given curve. All right. So when we say the point must satisfy the given curve, it means that whenever you plug in the x and the y component, the left-hand side must be equal to the right-hand side, all right? So the moment you have a curve passing through a point, it implies that the coordinate of the given point must satisfy the given curve, all right? So that's what we are going to apply here. So let us get started. So we have our solution here. So let us write our curve. Our curve is y is equal to ax squared plus bx minus 3, all right? And it passes through the point P with x coordinate of 1 and y coordinate of -5, all right? Since the curve passes through the point P, it implies that the x and the y coordinate of the point P must satisfy the given curve. So we are going to plug in this value. So wherever you see x, you put 1 over there, and wherever you see y, you have to put -5 over there. So we have -5 in place of the y, then we have it equal to a multiplying 1 squared because x is equal to 1 plus b also multiplying 1 minus 3, all right? We are going to get -5 is equal to a plus b minus 3 over here. So we are going to get it as -5. We are grouping like terms plus 3. We have transposed the 3 to the left hand side. It is -3. So it becomes +3, all equal to a plus b. And we are going to get it as -2 is equal to a plus b. Right? So our first equation becomes a plus b must be equal to -2, which is our equation 1. All right. We have been given another condition that if the gradient if the gradient of the curve at P, all right, if the gradient of the curve, if its gradient at P, it should be a P. All right, let me correct it here. It should be at P. If its gradient at P is 2, all right. So this is what we are going to do. So it implies that if the gradient at P, that's P with x coordinate of 1 and y coordinate of -5 is 2, that it implies that our dy dx must be equal to what? 2. All right. So let us find our dy dx. That is the gradient function. So we bring our function back, which is y is equal to ax squared plus bx minus 3. So we are going to differentiate. So we have dy dx equal to 2ax plus b, all right? Okay, but we have the gradient at point P, so we have x coordinate of the point P to be 1. So we have to plug in the value of the x coordinate, all right? So we have 2a times 1, that is the x coordinate at where the gradient is equal to 2. then plus b. Then we have it to be equal to 2a plus b. All right. But at that point, the gradient is equal to this our gradient. But it is given that the gradient is equal to 2. So we are going to get it as 2a plus b must be equal to what? 2. And that will give us our second equation. All right. So we are going to solve equation 1 and equation 2 simultaneously. Let us go for equation 1. We have equation 1 to be a plus b. So that is I'm repeating the equation 1. A plus b is equal to negative 2. Let me verify again. All right. A plus b is equal to negative 2. So we can now solve the two equations simultaneously. So this is my equation 1. So you can see that the b here and this b have the same coefficient, and all the coefficients are positive. So since they are positive, we are going to subtract so that we can eliminate the b. We are using the elimination method, so we can write it as equation 2 minus equation what? 1, or equation 1 minus equation 2. You are going to get the same answer, please. So it's going to be, my equation 2 here is 2a plus b is equal to 2. Then my equation 1 is a plus b. So I'll put the a plus minus, I'm subtracting. A plus b then equal to negative 2. All right. Then I'll underline nicely. I'm subtracting. So 2a minus a will give us a. B minus b will give us 0. Then we have here to be 2 minus negative 2 give us positive 4. All right. So the value of a is 4. Okay. We have obtained the value of a to be 4. So we can now put the value of a into any of the equations. We have one of the equations to be a plus b is equal to negative 2. Right. You can use any of the equations. Okay. But I'm using equation 1. So, but a is now equal to 4. So we just plug in the value of a. Wherever you see, you put 4 over there. So a plus b, which is 4 plus b, must be equal to negative 2. So we are going to make b the sub here, and that will be, you transpose the 4 to the right hand side. It's going to be negative. So negative 2 minus 4 will be the value of b. So b becomes negative 6. All right. B becomes negative 6. So we conclude that a is equal to 4 and b is equal to negative 6. All right. Now this is the I part of the problem. Let us look at the I part. All right. This. So we are going to look at the I part, which says that we should find the minimum value of y. Right. After we have obtained the values of a and b, we need to plug in the value. So let us bring back the function. Y is equal to ax squared plus bx minus 3. All right. So wherever you see a, you put 4 over there. Wherever you see b, you put negative 6 over there. So y now becomes 4x squared minus 6x minus 3. All right. Now we are to find the minimum value of of y. That is the function. Okay. Now we should know that at the moment you have the coefficient of x to be positive, it means the curve will give us a minimum value. So it means the curve will be in this form. Let me draw it well. Curve doesn't look nice at all. Okay. So this is our minimum point. So here becomes our minimum. So we have our minimum point over here. All right. Now we have to find a minimum value. Right. So let us assume that we have our x and y axis over here. So let us assume that we have it over here like this. Okay. Okay. So when you trace it to the y axis, the value that you are getting for the y becomes the the minimum value. So this is the minimum value. Okay, this is the minimum value. Then when you trace it to the x, this is where it occurs. Okay, this is where it occurs, which is the same as the equation of line of symmetry. Okay, so here will be the where it occurs. So where the minimum value occurs, all right. But the focus is on the minimum value. So you can see that at the minimum point, you can consider that point to be the turning point. You see, the curve turns at the minimum point. And when you have the maximum to the curve turns at that point. So it means the curve started from this place up to here. See, this direction up to here. And it turns when it get to the minimum, meaning it cannot move down again. So it has to turn to move upward. All right. So at minimum, that's where we also get our turning point. So we know that at turning point, the gradient is equal to 0. That is, we have a tangent here, okay? And this tangent is parallel to the x-axis. And anytime you have a line parallel to the x-axis, it has a gradient of what? 0. So you could say that the tangent touches the curve at that particular turning point. So we say that at turning point, dy dx is always equal to 0. That is, the gradient is equal to 0. All right. So let's continue. So we are to find the minimum value, meaning we get the minimum value at the turning point. That is the minimum point. So we know the minimum point to be the x and the y coordinate. But here we are focusing on only the y, all right? And we know that at turning point, the gradient function is equal to 0, right? So this is what we are going to do. We have our function to be y is equal to 4x squared minus 6x minus 3. So we are going to differentiate it. Dy dx will give us 8x minus 6, all right? And at turning point, dy dx is equal to 0. So we are going to get 8x minus 6 equal to 0, okay? So we make x a subject. You have 8x equal to positive 6. I've transposed the negative to the right-hand side. So we are now going to get 8x equal to 6. Then we divide through by the coefficient of x. All right. So we are getting x to be 3 divided by 4. So this is the value of x at that particular point. But that is where the minimum value occurs. But that's not the minimum value. This is the corresponding x value when it comes to the minimum point. So we are going to use this value to get the corresponding y value, which becomes the minimum value. All right. So we have our function to be y is equal to 4x squared minus 6x minus 3. So wherever you see your 4, sorry, wherever you see your x, you are going to put the value of x value. So 4, then 3 divided by 4 squared minus 6, also multiplying 3 divided by what? 4, then minus 3. All right. Then we have everything. So we have 4 multiplying 9 divided by what? 16. All right. Then here too we have the numerator to be 18 divided by what? 4. Then minus 3. So here we have 4 divide 16, we get 4. 4 divide 7, we get 1. All right. Here 2 divides 4, we get 2. Then 2 divides 18, we are going to get 9. All right. So here we are going to get it as 9 divided by 4 minus here to be 9 divided by 2, then all minus 3, all right? So we can now find the LCM. The LCM will be 4. You can equally use your calculator. So here will be 9, then 2 divides this 4. We are going to get 2, so times 9 will give us 18, negative 18. Then here 4 times negative 3 will give a negative 12. And we are going to get a result of, so here we are going to get negative 21, all right? Then negative 21 will be the answer. Let me verify. All right. Okay, that's it. Negative 21 divided by what? 4. All right. Okay, which is the same as the y. So this becomes the y value at the minimum, all right? So we conclude that therefore the minimum value is equal to negative 21 divided by 4. Okay, let me verify again. Okay, I don't want any mistake. All right, so I'm dealing with the substitution again. I want to verify that part again. So 4 multiplying 3 divided by 4, or in bracket squared, okay, then minus 6, also multiplying the bracket of 3 out of 4, then minus 3, all right. So that's the answer, okay. You can equally use a different method to determine the minimum value. That is a method of completing of squares. So let us look at that one as well. Okay, you can equally use that one. So the I we are using another method to solve. So that is, you can equally use the method of completing of square. So we have our function to y is equal to 4x squared, then minus 6x minus 3. Right. So when you are using the method of completing of square, you have to make sure the coefficient of x squared is 1. All right. So you need to factorize 4 out. It's going to be 4 out. Then divide through by 4. Okay. So it's going to be, here will be x squared, and here will be 6x divided by 4. Then minus 3 also divided by what? 4. Okay. So we are going to get it to be 4 multiplying x squared minus 3. Okay. 3x divided by 2, because 2 divides 4 get 2, 2 divides 6 we get 3, all right? Then minus 3 divided by what? 4, all right? Now, we are now going to identify our b, all right? So we have the coefficient of s to be the b. So our b is equal to negative 3 divided by 2. Then you now find half of b, okay? So our half of b will be half of negative 3 divided by what? 2, okay? And this will give us a result of negative 3 divided by what? 4. All right. So this is what we are getting. So this is our half of b. So our half of b is equal to negative 3 divided by 4. So this is what we are going to do to complete the square. We are going to add it to the expression, then after that you subtract. Okay. It's like you have 10 series. If you have 10 series and you have added 2 series and you subtract 2 series again, you still get your 10 series back. All right. So that's the idea that we are using over here. So we have our y to be equal to 4 outside. Then we have x squared minus 3 divided by 2x. Then we add the half of the b, all right, the coefficient of x squared. So negative 3 out of 4 squared. Then minus the same thing, negative 3 out of 4 also squared. We are subtracting because this minus this, the 2 give us 0. So it doesn't add anything to the expression. Then plus the constant term, which is negative 3 divided by what? 4. And close your bigger bracket. So we continue. We are going to get it as 4 outside. Then the whole of this, let me use different color. So from here, okay, it's the same as you just pick the x here. You see, then minus, you pick what is inside the bracket also. Yeah, so we have negative 3 out of 4 in the bracket. So negative 3. So that is why we have, it should be x plus. But because here is negative, the term in the bracket has a negative, so it's going to be minus 3 divided by what? 4. All right. Minus 3 divided by 4. Then you square everything. So we have covered the whole of this. We are done with that. So we are left with minus. So we have negative 3 over 4 squared. Then minus 3 out of 4. Then bring your bracket nicely. I know that some people will not like this one. They will use the calculus to use a differentiation approach. So here we are going to get it to be 4 multiplying x minus. Okay, there should be a bigger bracket here. Let me close it well. Because the 4 is multiplying everything. Okay. Okay, it's now okay. So we have, let me bring another bigger bracket first. So x minus 3 divided by 4 squared in one bracket. All right. Then we have, let's now work on this. Negative 3 squared will give us 9. Then divided by 4 squared is 16. Then minus 3 divided by what? 4. Close it nicely. Okay. So we continue. We have 4 multiplying a bracket of x minus 3 divided by 4 squared. Multiply another, which is we have here to be 16. So let's find the LCM for this part. Let us simplify this part. Okay, so their LCM will be, so plus the LCM will be 16. Okay, so 16 divided itself 1 times negative 9 will give us negative 9. Now 4 divided 16 4 times negative 3 will give us negative 12. Then close it nicely. So we are going to get it to be 4 multiplying x minus 3 out of 4, or in bracket square. Then the same 4 will be multiplying. So we now have negative 21 divided by what? 16. Then we close it nicely. All right. So we can now expand the bracket. So we are going to get it as 4 multiplying x minus 3 out of 4 squared. Then negative 21 divided by 16 also times what? 4. Okay. We are going to get it as 4 multiplying x minus 3 out of 4 squared. Then here we need to simplify. 4 divided itself 1. 4 divided 16, we have 4. All right. We are going to get it as negative 21 divided by what? 4. Right. So this becomes our maximum or our minimum value. But because the coefficient of the x square is positive, it means the negative 21 divided by 4 becomes the minimum value. And where it occurs will be the one inside. The x minus 3 divided by 4, you equate it to 0, then you get the x value. That is the equation of line of symmetry. But the question doesn't involve equation of line of symmetry. So we are just going to pick the term outside. So suppose you have it in this form. So this is how the expression should be. So x, then you have it as plus or minus. Okay, let me put it over here. Then square, then you can bring here 2 to be, here 2 can be plus or minus what? C, or let me put B over here. Okay. Okay. So the plus or minus B determines your maximum value or your minimum value. Okay. And what we have here, the plus or minus, the x plus or minus B is used to obtain where the maximum or the minimum value occurs. All right. So if you're okay with the first method, then you don't need to use the second method. All right. So you could say that here to minimum, our minimum value will be the same as negative 21 divided by what? 4. All right. Okay. So that's how we go about it. If you're okay with the first method, that's the differentiation approach. Stick to that one. If you're not okay with this one, then I think you can use this one, because this one, I think it has been treated under quadratic equations and functions. All right. Using the method of completing of squares. Thank you for watching. Please do not forget to subscribe to my YouTube channel, which is Maths with Ebefa. Bye.